Welcome to STEM Pathway. Today, I want us to discuss
this paper, and I'm coming live from Nyayo National Stadium, where we'll be revising key topics from Grade 9 Integrated Science Midterm Exam. In this video, each question will be handled from different parts of the stadium, making learning more interactive, fun, and easier to remember. We will cover key topics such as the internal and external part of a leaf, photosynthesis, osmosis, diffusion, the fire and the fire triangle, laboratory apparatus, atoms and electronic arrangement, metals, non-metals, pressure, nutrition in animals, alloys and adolescents. If you are a new member, welcome and don't forget to subscribe. And if you are a regular member, welcome back and don't forget to leave your comment. Our team will respond to you as soon as possible. Let's get started. So the first question is, the diagram below shows the internal structure of the leaf. Study it and answer the questions that follows. So in this case, we have this internal structure of the leaf with layer A and then layer B. Layer A is what we call the palisade mesophyll, and then layer B is what we call the sponge mesophyll. Then we also have part C, which is the stoma or the stomata. Then now let's go to the questions. A, identify the layers labeled A and B. So the layers which are labeled A and B here is that A is what we call the palisade mesophyll. Then we have layer B, which we call the spongy mesophyll. These two layers are composed of chloroplasts, which are responsible for what we call photosynthesis. Then question B, what is the function of the part labeled C? This part labeled C here, we call it a stoma or a stomata. And in this case, this is a small hole which allows particles, especially gaseous particles, to come in and out of the cell. Also, it also allows water to move out of the cell in what we call transpiration. So in this case, the function of the part labeled C, which is the stomata, it allows for gaseous exchange, that is carbon dioxide coming in because it's a raw material for photosynthesis, and also oxygen moving out because it's a byproduct of photosynthesis. And again, these stomatas or these holes, they allow what we call transpiration, that is the movement of water vapor out of the leaves. Then question C, outline two ways in which the chloroplast is adapted to its functions. These chloroplasts, these are sites for photosynthesis where the light stage of the photosynthesis and the dark stage of photosynthesis take place. So these chloroplasts are adapted in such a way that, one, they contain chlorophyll, this is the green pigment, to trap solar energy or light energy. They contain chlorophyll, which is used to trap solar energy. And then the second adaptation is that they are mobile. They can move within the cell toward the way from which light is coming from. So these chloroplasts can move within the cell toward the way or towards or away from the light intensity. So if there's less light below the leaf, they can move up to where light is and absorb as much light as possible, because light is one of the major components of photosynthesis. Question 2, the diagram below shows the setup for an experiment to investigate whether carbon dioxide is necessary for photosynthesis. So in this case, the setup that you see here is used to investigate if or whether carbon dioxide is a condition necessary for photosynthesis to take place. Now, the plant was detached before the apparatus was set up as shown in the diagram in a sunny room. So in this case, you can see we have this plant. This is the plant that we have here. This is the plant. Then we have this substance C. We are going to see the name of that substance. Then we have this one of the leaves, which is now placed inside this bottle, and part of this leaf is left out. You can see here, there's a part of this leaf here which is left out, and then some part of this leaf is left in. And now when this leaf is removed, we have part A, which was left out. This one was out, and then this other side was inside the bottle. And then the first question is, name the liquid marked C. Now in this case, the liquid marked C, since we are investigating whether carbon 4 oxide is a condition necessary for photosynthesis, then here we need a substance which can remove carbon 4 oxide from the experiment. And some of the substances which we can use to remove carbon 4 oxide from the environment is either potassium hydroxide or sodium hydroxide solutions. These two solutions absorbs carbon 4 oxide from the environment. Then question B, identify the function of liquid C. Now the function of this liquid C, as we have just said, is to remove or to absorb all carbon dioxide from the air inside the flask. So in this case, we would have eliminated carbon 4 oxide from the process. Therefore, the inner part of the leaf does not have carbon 4 oxide. And if carbon 4 oxide is a condition necessary for photosynthesis, then the part which is inside this bottle photosynthesis will not take place. Then question C, after the leaf was tested for starch, what result can be seen in part A? The part A here, this part was outside the bottle, so it had all the conditions necessary for photosynthesis. And therefore, in this case, in part A, photosynthesis took place. And if you do a starch test, then it will test positive, where this leaf will turn blue-black. So in this case, we will say the leaf part turns blue-black, indicating that the starch is present. Starch is present in part labeled A because this part was outside the bottle, and therefore outside the bottle, because we have air, we have carbon 4 oxide, which is a component of air, we have sunlight, and then those are the conditions necessary for photosynthesis. Then question D, explain one reason for the result at B. At this part, which we have called now B, let us indicate it with blue. This part called B, it was inside this bottle where there was no carbon 4 oxide. Therefore, in this case, one of the conditions, which is carbon dioxide, was not present, and therefore photosynthesis did not take place, and the color will not now turn to blue-black. Therefore, in this case, we will say the leaf part remains brown or yellow, because that is the color of iodine. This is because of lack of carbon 4 oxide. Inside that bottle, there's lack of carbon 4 oxide because all the carbon 4 oxide was absorbed by potassium hydroxide or sodium hydroxide, the one that was used. And in this case, photosynthesis is prevented. Question 3, a group of learners set up an experiment to investigate a certain physiological process. So the setup was shown is as shown below. So in this case, we have the inner part here. We have an unripe piece of peeled pawpaw, and then we have we also have here the concentrated sugar solution, and then we have water. So inside this purple piece, we have concentrated sugar solution, and then we also have water from outside. Then what physiological process was being investigated? In this case, the physiological process being investigated is what we call osmosis, and osmosis, we define it as a process by which water moves from where it is highly concentrated to where it is lowly concentrated through a semi-permeable membrane. So this part here, this part where this solution is placed inside is act as a semi-permeable membrane, and the process where now this water will have to move from outside where it is highly concentrated to inside of this purple piece where it is lowly concentrated, we call it osmosis. Then question B, account for the rise of the level of sugar solution in the experiment. The reason why this sugar solution rised is because of osmosis, where water molecules moved from the beaker. Look at this, we have a beaker outside here, we have water. Now these water molecules move from inside this beaker into the part where we have a sugar solution, and in that case the level of water or the level of the solution increased because water molecules moved from the beaker where it was highly concentrated to inside the living purple cells where it was lowly concentrated, and it moved through this semi-permeable membrane. Then question C, give two roles. In this case, we could have used the word roles. Give two roles of the process in A above. Now, two roles of osmosis. One of it is that it's used in absorption of water by a plant roots in the root cells. We also have another role as in maintaining cell turgidity, that is in supporting of the plants, and also it can be used in opening and closing of the stomata. Question 4. A student in a school workshop accidentally knocks over the spirit lamp, causing a small fire on the wooden workbench. To put out the fire, the student quickly covers it with a heavy, damp fire blanket. So this student covered the small fire with a heavy, damp fire blanket. So the first question, identify the three essential components required for a fire to start and continue burning. The three essential components of a fire, we study them in what we call a fire triangle. And in this case, a fire triangle has three components. The first one is what we call heat. Then the second one is fuel. The third one is oxygen. And we can arrange them in a triangle like this one here, the one that you can see on the screen, where this triangle contains heat, then fuel, then oxygen. So for fire to be started and to continue burning, you must have heat, fuel, and oxygen. Then question B, explain how the uses of a fire blanket, the one that the student used, helps to extinguish the fire in terms of the component mentioned above. In this case, this fire blanket will cover the fire by preventing oxygen from coming in, and in that case you could have prevented oxygen as a component of a fire triangle, and in the process the fire will be put off because there will be no oxygen. So in this case we can say the fire blanket stops the fire by cutting off the supply of oxygen. So the way this fire blanket puts off this fire is by cutting off the supply of oxygen, and if you cut off the supply of oxygen, as you can see from this fire triangle, you stop that fire. Question 5. Leaves are the organs of photosynthesis. The following diagram shows what happens in a plant leaf during photosynthesis. Remember, photosynthesis is a process where plants or green plants make their own food using simple available materials like sunlight, water, and carbon dioxide. So in this case we have a leaf, and this leaf, as you can see, we have sunlight coming in. As you can see through these arrows, we have sunlight which is coming into the leaf. Then down here we have water from the roots, and then we have sugar going to the rest of the parts of the plant. Then here we have gas X, which is coming into the leaf, this gas X, and then we have gas Y, which is moving out of the leaf. Then the first question is, give two ways in which leaves are adapted to absorb sunlight. The way leaves are adapted to have maximum sunlight is that, one, they have a large surface area. Leaves have are very broad to absorb maximum amount of light. Then the second adaptation of these leaves is that they are very thin, that is making the distance short for light to penetrate. Then another one is that they have many chloroplasts. Remember, chloroplasts are site for photosynthesis. Chloroplasts which contain chlorophyll, which is a green pigment in green plants which absorbs light energy. So these chloroplasts are concentrated in the pulsate layer, the upper part of the leaf. Then question B, name the gases labeled X and Y. The gases labeled X, in this case, the gas which is coming in is a gas which is required during the photosynthesis process, and this is carbon dioxide. Carbon dioxide as a gas is the one which is coming in, and then the gas which is leaving out is a byproduct of photosynthesis, that is oxygen. So we can say the gas labeled X is carbon dioxide, which is entering into the leaf, and then the gas labeled Y is oxygen, which is living because it's a byproduct of photosynthesis. After sugar is manufactured or starch, then the rest of the gases which are produced in the process, which is oxygen, is left to the environment as unwanted gas. Then question 6, identify the following pieces of equipment found in a science laboratory and state one function for each of them. So in this case, we have two apparatuses here. We have apparatus A and then we have apparatus B. Apparatus A is what we call a conical flask. This is a conical flask. And then apparatus B is a graduated beaker. This is a graduated beaker. So in this case, we are supposed to identify them and then name the function of each of them. So here we have A, which is a conical flask, as we have said, and its function is used for swirling liquids during titration or mixing chemicals without spilling. You can see if you swirl chemicals inside, you cannot spill them out easily because of its conical shape. Then apparatus B is that it's called a beaker, but in this case you can see it's graduated because it has a scale here, so we call it a graduated beaker, and its function is for holding, mixing and heating liquids in the laboratory. Then we have question 6. Phosphorus has atomic number 15 and its electron arrangement is 285. Draw the phosphorus atom showing the nuclear and the 3 energy levels or level shells. So in this case, what you need to do is first to draw the nuclear of this phosphorus, where you draw it like that. Number of protons are 15, that is atomic number. Then you draw the first energy level, the second energy level, and the third energy level. And now we can place the electrons that we have in these energy levels. Remember, the first energy level, we get it from this electron arrangement up here. There are 2 electrons, 1, 2. Then the second energy level, we have it here. It has 8 electrons. So we have 1, 2, 3, 4, 5, 6, 7, and 8. And then we have the third energy level, which has 5 electrons, and we can write them here: 1, 2, 3, 4, and 5. So in this case, what we have drawn is the energy level diagram showing the atom of phosphorus. Then question 7, a glass prism has a rectangular shape of 1.2 meter by 0.75 meter. It has a mass of 9 kg. Calculate the pressure exerted by the prism on a flat table, where we have the gravitational field strength as 9.8 kilogram per kg. In this case, what you need to do is first calculating or writing the formula of pressure is equals to force over area. And in this case, we can get our force, which is the same as the weight of the rectangular block, which we can get as mass times the gravitational field strength, which is in this case 9 kilogram times 9.8 Newton per kg. And in this case, what we will get as our force is equals to, our force in this case is equals to 88. This is 88.2 Newton. That is our force. Then the second step is finding the area. Area in this case is length times width, which we can get as, our length is 1.2 meter, then our width is 0.75 meter. Therefore, in this case, we are going to get our area. We are going to get our area as 0.9 square meter. Now, in this case, we have force as 8.2 Newton. Then we have area as 0.9 meter. Therefore, now we can find pressure, and we can say pressure is equals to force over area, which is in this case, our force is 88.2 Newton, then divided by 0.9 square meter. So our pressure is equals to 98. This is 98 Pascal, or we can just simply say our pressure is equals to 98 newtons per square meter. So that's how you can calculate the pressure of that glass prism. Then another question, categorize the following elements based on their physical and chemical properties. So in this case, we have different elements here. We have iron, so we can write iron here. The first one that we have here is iron. Then we have oxygen, we have copper, then we have sulfur, we have magnesium and carbon. So in this case, we are supposed to categorize them as either metallic elements or non-metallic elements. And in this case, I want to give you a hint on how to identify metals and non-metals in the first 20 elements. If you write the electron arrangement, for example, for sodium, which we write as Na, for sodium, which is atomic number 11, its electron arrangement is 281. Then another one like sulfur, for example, sulfur, whose symbol is S, its electron arrangement is 2, 8, then 6, which is atomic number 16. In this case, if you have an element whose electrons are less than 4, that is 3, 2, 1, like sodium, this in this case is going to be a metal. If it has 2 electrons in the outermost energy level, 1 electron in the outermost energy level, or 3 electrons in the outermost energy level, it's a metal. But if you have an element whose electrons in the outermost energy level are greater than 4, that is 5, 6, 7, and 8, and in this case, like our sulfur, it has 6 electrons in the outermost energy level. These are non-metals. So that's how you can identify metals and non-metals from the first 20 elements. So in this case, we have iron. Iron is a metal, we know that. So here we have iron. Then we have oxygen. Oxygen, its electron arrangement is 2, 6, that is a non-metal. Here we have oxygen. Then we also have another one, we have copper. Copper is a metal, so here we have copper. Then we have sulfur. We have said it's a non-metal, sulfur. Then we have magnesium, atomic number 12, electron arrangement 282, this is a metal, magnesium. Then we also have carbon, atomic number 6, electron arrangement 4, this is a metalloid, so it's a non-metal at its natural state. Question 9, study the dentition diagram belonging to an animal. So in this case, you can see this dentition diagram where we have a major identity here, which is a gap which we call a diastema. And this one belongs to animals like cows, which feed purely on greens. And the first question is, identify the likely mode of nutrition. The likely mode of nutrition in this case is for the animals which feed on greens, and we call them the herbivores. So in this case, question B, name the toothless gap marked B and explain the function during feeding. As we have identified, the feeding or the toothless gap is called a diastema, and its function is to provide space for the tongue to manipulate food and separate chewed food from the unchewed food during grazing. Then question 10, a thistle funnel is covered with a semi-permeable membrane filled with a strong sugar solution and placed in a beaker of pure water. So in this case, we have a thistle funnel, and then it is covered with a semi-permeable membrane and then filled with a sugar solution. So inside we have a sugar solution, and then this one is placed inside pure water. So we have now two differences in gradient. In this case, we have where we have high sugar solution, and then we have where we have pure water. Explain why the level of the sugar or of the solution inside the funnel rises after 1 hour. In this case, if the solution inside the funnel raised, it means water moved from the beaker where it was highly concentrated to inside the funnel where it was lowly concentrated, because inside the funnel we had a sugar solution. Therefore, in this case, a process where water moves from where it is highly concentrated to where it is lowly concentrated, we call it osmosis. So to explain this, you can say this happens due to osmosis, and water molecules move from an area of high water potential or concentration, that is the pure water in the beaker, to the area of low water concentration or potential, that is where there is sugar. Remember, sugar has few particles of water, but when we have pure water, we have more particles of water across this impermeable membrane which was engulfed in this thistle funnel. Now, this movement of water from the beaker to the thistle funnel where we had less water concentration causes the increase in volume of the solution in that funnel. So purely this process is osmosis. Question 11. A learner finds a skull with very long pointed canine teeth. Question A. What is the likely deity of this animal? The likely deity of the animal with a very long pointed canine teeth is what we call a carnivorous. And in this case, another question is, how do these specific teeth help the animal to survive in their environment? In this case, they use these long pointed canine teeth. They use them for piercing, gripping, and killing prey, and for tearing flesh from the bone. Remember, these teeth are very sharp, and they can tear flesh and also even kill the prey. Question 12. Brass is an alloy. Remember, an alloy is a mixture of two or more metals, or a metal with a non-metal with an essence of making it strong. So brass is an alloy commonly used to make musical instrument and plumbing fixtures. Name two metals that are melted together to form brass. For you to form brass, you need two metals, and the first one is copper, then the second one is zinc. And when you make this brass, which is now a mixture of copper and zinc, it becomes more strong and even more durable and cannot rust easily. Then question 13, state two differences between burning of a piece of paper, that is a chemical process, and melting of an ice cube. If you burn a piece of paper, you are doing a chemical process. But if you are melting ice cube, you are only doing a physical process where you are changing state from solid, which is the ice cube, to a liquid, which is water. Therefore, in this case, in short, they are asking us to give the differences between chemical change and the physical change. And the first one is that in melting ice is a physical change. It can be reversed, but burning a paper is a chemical change which is irreversible. That is the first difference. Then the second difference is that there is no new substance formed in melting ice. The water remains water, only in different states. Water in solid state is called ice. Water in liquid state is called water. So in this case, there is no new substance. But in burning of a piece of paper, carbon dioxide is produced, water vapor is produced, and even ash are formed. And therefore, in this case, there's a new substance formed for this irreversible process, and much more differences that you can give. Question 14. Cramp pain is one of the challenges that came with adolescence. Suggest two ways that girls can deal with cramp pains. There are very many ways in which girls can deal with cramp pains, and one of it is that they use hot water bottle on the abdomen. They place hot water at the abdomen. The second one is to do gentle exercises like stretching. Then the third one is staying hydrated, taking some good amount of water. Then the fourth one is taking over-the-counter pain relief. So you can take the over-the-counter drugs for you to relieve your pain. Then question B, state two physical changes that affect both boys and girls during adolescence. There are very many physical changes that takes place in either boys and girls during adolescence, but one of it is that there's growth of spurts, increasing height, and weight. So in this case, these teens, they all boys and girls both experience a sudden increase in height and weight. Then the second one is growth of pubic and underarm hair. They both experience for both boys and girls. Then the third one is appearance of pimples on the face for both boys and girls. Question 15. Use the information in the table below to answer the question that follows. The letters do not represent the actual symbols of the element. So we have an element and its atomic number and then mass number. Element W, its atomic number is 18, mass number 40. Element X, atomic number 3, mass number 7. Element Y, atomic number 5, mass number 11. Then we have element Z, atomic number 20, mass number 40. Then the first question, write the electronic configuration of element W. Now for us to find the electronic arrangement of element W, then we must know the number of electrons, which are found in this element W. So in this case, how do we get the number of electrons? We know the number of protons is equal to the number of electrons in an electrically neutral atom. And this number of protons is the same as atomic number. Therefore, in this case, since we know atomic number of element W is this 18, therefore the number of electrons is 18 electrons. Now, these electrons are arranged in different energy levels, where we have 2 electrons in the first energy level, then we remain with 16 electrons. Then 8 electrons goes to the second energy level, 16 minus 8, now it's 8. Then 8 electrons will go to the third energy level. So now element W has electron arrangement of 2 to 8 to 8. That is now the correct answer. Then question B, how many electrons are there in the outermost energy level of Z? Remember Z, which we have here, atomic number 20, mass number 40. It means this Z, its atomic number is 20. It means it has 20 protons and then 20 electrons. Now these electrons, we can arrange them in different energy level, where now we will have 2 electrons in the first energy level, then we remain with 18 electrons. Then 8 electrons in the second energy level, we remain with 10 electrons. Another 8 electrons in the outermost energy level, we remain with 2 electrons. And then 2 electrons now will go to the outermost energy level. Now the question was asking how many electrons are there in the outermost energy level of Z. Therefore, in this case, for Z, it has 2 electrons in the outermost energy level. So you will write your answer as 2 electrons. These are 2 electrons in the outermost energy level of element Z. Then question C, give the number of neutrons in an atom of X and Y. The number of neutrons in element X and Y. In this case, what you need to know is that for us to get mass number, we get it by subtracting, by adding atomic number plus number of neutrons. And remember, this atomic number is the same as number of protons. Therefore, in this case, for element X, we have its atomic number as 3 and then mass number as 7. So in this case, for us to get number of neutrons, therefore, we will have to have mass number. We subtract atomic number, we will get the number of neutrons. Therefore, for Z or for X, for element X, it is number of neutrons is equals to 7 minus 3, which is going to be 4. That is the number of neutrons in element X. And then for element Y, element Y has atomic number 5. We write it down here, and mass number 11. Therefore, for us to get number of neutrons, then we are going to get 11 minus 5, which is going to be 6 neutrons. So that's how you can calculate that. Then question 16, draw the electron arrangement in a potassium atom using a dot or a cross diagram. So remember, potassium, which we write as capital K, it's atomic number 19, and in this case, this atomic number 19, we can use it to get the number of electrons. Therefore, it means this potassium has 19 electrons, because the number of electrons and the number of protons are always equal for an electrically neutral atom. Therefore, in this case, if you know the number of electrons, then you can write the electronic arrangement. And in this case, the electronic arrangement of this potassium is 2 electrons in the first energy level. Then we have 17 electrons remaining. Then 8 electrons goes to the second energy level. We have 9 electrons remaining. Another 8 electrons in the third energy level. Then we have 1 electron in the outermost energy level. This is the electronic configuration of potassium. But now we are supposed to draw a cross or a dot diagram. In this case, we draw the nuclear, where we can write the symbol of the element as potassium. Then we draw the first energy level, where we will have 2 electrons, as we have seen, 1 and 2. Then now we draw the second energy level, where we can draw 8 electrons, 1, 2, 3, 4, 5, 6, 7, and 8. Then we have the third energy level. Which also has 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Then now we also have the fourth energy level. We have the fourth energy level here, which we can draw it. Let me use this ink, which you can draw like that. The fourth energy level, which has only 1 electron, so you can draw it there. So that is the cross diagram for a potassium atom.
And that will mark the end of this lesson. If you are a new member, don't forget to subscribe. And if you are a regular member, don't forget to leave your question on the comment section. Our team will respond as soon as possible.